This video, we're going to discuss the factor theorem, which tells us that if we can divide and get a remainder of 0, that the factor that we're dividing by goes in evenly, and we can factor the polynomial with that as one of the factors. Specifically, if I have n of x divided by d of x divides evenly into n of x, we get q of x with no remainder. And n of x equals d of x times q of x. So that's what we're going to be trying to prove here. I'm going to show you one example with long division because you're going to need to know it if the divisor is not linear. However, all of these divisors that we're trying to divide by here are linear. So that means we're going to be able to use synthetic division here. And synthetic division is much more useful in this chapter, especially when we get into the rational root theorem. So I want you to practice with synthetic division, as this long division of polynomials should be a skill that you have already practiced in other algebra classes before this one. Synthetic division may be new to you. We do not have any missing degrees in our dividend there, so we're going to take the first term in our divisor into the first term in our dividend. X cubed divided by x is going to be 1x squared. Multiply x squared times x plus 9, get x cubed plus 9x. We're going to subtract now by changing our signs and adding. Now we're going to bring down. We're going to do the same thing again. Negative 2x squared divided by x is a negative 2x. It's a negative 2x squared. It's a minus 18x. We're going to change our signs and add. 2x divided by x. It's going to be a positive 2. Change my signs and add, and I get a remainder of 0, which means to me that x cubed plus 7x squared minus 16x plus 18 is going to be equal to x plus 9 times x squared minus 2x plus 2. I could factor that last part again. No, I cannot, excuse me. I thought that was plus 1. So we're done factoring that for right now. Let's go ahead and let's show the same thing with synthetic division. If I had taken the x plus 9 and set it equal to 0, x would be equal to negative 9. That's going to be my 0 that I'm going to use for synthetic division. Put my 0 on the outside. I put the coefficients from the dividend, not skipping any terms. So if there's a missing term, I'm going to put a 0 for its coefficient, like so. Bring down, multiply, add, multiply, add, multiply, add, and I'm looking for a remainder of 0 over here. That tells me again that this is x plus 9. Now watch out that all of these coefficients have dropped a degree. So this is not a 1x cubed anymore, it's a 1x squared minus 2, and the degree now is 1 on that term, plus 2, this last term here before the remainder should be my constant. And that's the same thing that we got when we did long division. So you can see that synthetic division is going to be preferable most of the time here. So we're going to go ahead and use that to practice. X cubed plus 2x squared minus 6x plus 8. We want to check the divisor x minus 4. So we're going to set x minus 4 equal to 0 and get x equals to 4. We're going to put a 4 on the outside. 1, 2, -6, and 8. 1 times 4 is 4. Add and get 6. 2 plus 4 was 6. 4 times 6 is 24. 24 minus 6 is 18. You can already see that we're in trouble here, right? This is going to be 32 plus 4 is, 3 plus 4 is 7. There we go. This is 80. So this is, no, it's not divisible. These are just yes, no questions. So the first one was yes. Second one is no. Now we've got x to the 4th minus 12x to the 2nd. Watch out that we're missing the x to the 3rd term and we're missing the x term here. So again, x minus 4 equals 0, x equals 4. We're testing to see if that's a 0. We have 1, 0, -12, 0, -64. That's my x to the 4th term, my x to the 3rd term, my x to the 2nd term, my x to the 1st term, and my x to the 0 term, right? Bring down, multiply, add, multiply, add, multiply, add, multiply, add. I get a remainder of 0. So this is yes. Now let's try x to the 4th minus 5x squared minus 36 by x minus 6. This can be 6, 1, 0, -5, 0, -36. Should be pretty obvious by this point that it's not going to work. Something like that. And so, no. I have -11 for 0, 1, 11, 7, 73, -44. And there you have it. This one is yes. Ten is going to be our 0, 1, 10, 2, 14, -60. no. Okay. Let's go ahead and now do some with some fractions. Seven goes into 21 3 times. 3 times negative 11 is negative 33. This is negative 14. 7 goes into negative 14, negative 2 times. Negative 2 times negative 11 is a positive 22, is a negative 14. And multiply there again and get a positive 22. It's a 0. So this is a yes. Watch out with these when you are trying to get the other factor. This is fine because we were given it as x plus 11 over 7. But when you get something with a coefficient that's not 1 and you solve for the 0, you're going to have to make an adjustment in the quotient to adjust for that. So let's just set up the next problem here. 3104, negative 40, and negative 66. 3 goes into 30 10 times. It's 110. This is 214. This is already not going to go in evenly. If I wrote everything down correctly, and I did. So we're going to get a fraction here, and then we're going to keep getting fractions of fractions, and there's no way that it's going to come out to be 0 over here. So this is 71 and 1/3 times 11. It's not going to work. Let's just say no. We don't even need to keep going here. Can if you want to, but there's really no reason to keep going here. So let's clear that one out. -2 for our 0. And we've got 6, 11, -2, 1, and -2. 6 times -2 is -12. We're going to add to get a -1, multiply to get a +2, add to get a 0, multiply to get 0, add to get 1, multiply to get a -2. And that gives us a -4. So this is no. -3 on the outside here. 8, 23, 3, 1, 3. 8 times -3 is -24. That gives me a -1. Multiply gives me 3. Multiply gives me -18. Multiply gives me a +51. That's a 54. It's not a 0. -3, 4, 10, -5, 3. It's a -12. Adds to give me -2. Multiply to give me 6. Add to give me 1. multiply to give me -3. There's a 0. Yes. Have -3, 5, 12, -8, -3. Bring down the 5 and multiply by -3 to get a -15. Add with the 12 to give me -3. Multiply by -3 to give me a +9. Add with the -8 to give me a 1. Multiply by the -3 to give me a -3. It gives me a remainder of -6. So it's not a 0. Let's do just a few more here with this theorem, and we're going to actually do some factoring this way. If the 0, if the number that we're testing actually is a 0 that leads to a factor. 5, 37, 20, and 42. This is a -35. That's a 2. It's a -14 and a 6. -42 is a 0. So this gives me x plus 7 times 5x squared plus 2x plus 6. Now we have a -7 on the outside, and a 1, 7, 3, 17, -28. Bring down, multiply, multiply and add, multiply and add, multiply and add. So this can be x plus 7 times x to the 3rd plus 0x squared plus 3x minus 4. Three fourths, 12, 15, 18, -27. 3 times 3 is 9. 6 times 3 is 18. 9 times 3 is 27. So there's a couple different ways that I can write this. We've been writing it so far as x minus 3/4 times 12x squared plus 24x plus 36. But I see a common factor of 4 in all of these, actually of 12 in all of these terms over here. So let's factor that 12 out. Like so. And then I'm going to leave a 3 outside, but I'm going to put a 4 in here to get rid of this fraction. And then if I wanted to factor this completely, that's an x plus 1. Nope, that's not going to factor anymore. This is an x squared plus 2x plus 3. There are no factors of 3 that add up to be 2. So there it is. This would be an acceptable answer, but this is completely factored. And we've got 1 on the outside, 5, -9, 19, -27, and 12. Multiply and add, multiply and add, multiply and add, multiply and add. So that makes this x minus 1 times 5x to the third minus 4x to the second plus 15x minus 12. We can factor further. Remember, we can factor by grouping here. And that last one is an irreducible quadratic, so we're not going to mess with it anymore. And let's finish up with number 17 for today. Or 1, 0, negative 14, 0, negative 35, 0, 48. So that makes this x minus 4 times x to the fifth plus 4x to the fourth plus 2x to the third plus 8x to the second minus 3x minus 12. And we'll come back next time and we'll talk about Descartes' rule of signs and the rational root theorem or the rational zero theorem. Have a good night.